What if I told you there are 3 jobs, fully remote, no required degree, that regularly pay between $120,000 and $400,000 a year? I'm not talking about drop shipping or some side hustle grind. I'm talking about legitimate, high-leverage tech careers that the top 1% quietly get paid for. Today, I'm breaking down the product trio: PM, SWE, and product designer. What they actually do, what they earn, the exact skills and tools to get there, and how AI is reshaping all three right now. Stay till the end. I'm revealing the secret hack I personally used to break into product design. No bootcamp, no certificate, no connections. This hack works for PM, engineer, or designer, and in 2026, combined with AI tools, it works faster than ever before. The traditional path to a well-paying career: 4-year degree, entry-level job, slow climb. That model is cracking. In tech, what matters is what you can build, what problems you can solve, and what you can ship. Today, we map out exactly what each of these 3 roles builds, solves, and ships: the skills, the tools, and how AI is changing the game for all 3. The PM, SWE, and designer are the 3 pillars of every tech product ever built. Together, they form a complete product ecosystem. Separately, each is a 6-figure remote career on its own. Let's start with the role most people aspire to but least understand: the product manager. The product manager is often called the CEO of the product. They don't write the code, they don't design the screens, but they decide what gets built, why, and in what order. The morning starts with data. A PM opens their analytics dashboard, Mixpanel, Amplitude, or a custom SQL query, and asks, what happened yesterday? Did users drop off at onboarding step 3? Did the new feature see adoption? Data is the PM's North Star. By mid-morning, a PM is writing. The PRD, Product Requirements document, is their most critical deliverable. It answers, what is the user problem? What is the proposed solution? What does success look like measured in specific metrics? And what are the constraints? Midday is for people: sprint planning with engineering, design review with UX, and a stakeholder one-on-one to keep the roadmap aligned. PMs are constantly translating between audiences: engineers, designers, executives, and making sure everyone is building toward the same goal. Afternoons involve user research. A great PM is obsessively curious about users. User interviews, usability tests, customer calls, constantly asking, what pain haven't we solved? What are users doing that we didn't expect? End of day is strategy: updating the roadmap, prioritizing the next sprint. Writing. PMs write constantly: strategy memos, stakeholder updates, retrospective documents on what shipped and what the team learned. That's the day-to-day, but the day-to-day is powered by a specific set of skills. Let me break down the 7 core competencies that separate a good PM from a great one. Skill 1 is strategic thinking: the ability to zoom out from day-to-day execution and ask where this product should be in 12 months, 3 years. PMs translate business goals into product strategy and break that strategy into an executable roadmap. It's systems thinking, understanding how a change in one feature ripples through the entire product ecosystem. Skill 2 is data fluency. PMs live in data. They define KPIs, interpret A/B test results, and make product decisions backed by numbers. You need to understand statistical significance, know how to instrument features to measure what matters, and be able to walk into any room and say, here's what the data says, and here's what it means. Skill 3 is user empathy. The best PMs are obsessively curious about why users behave the way they do. They run structured interviews, watch session recordings, build personas, map journeys. User empathy is the antidote to the most common product failure: building features for yourself instead of your customer. Skill 4 is prioritization. With infinite things to build and finite engineering resources, you need a defensible framework for deciding what gets built first. RICE scoring: reach, impact, confidence, effort, Moscow method, the Kano model. These are the language you use to say no to a VP without burning the relationship. Skill 5, cross-functional communication. A PM is constantly translating technical constraints to a non-technical CEO, business goals to an engineer who wants to over-engineer, user needs to a stakeholder cutting scope. Written communication and verbal communication are equally critical. Skill 6 is technical literacy. You don't need to code as a PM, but you need to understand what's technically feasible and how to evaluate trade-offs. PMs who can read a basic API doc or sketch a system architecture earn instant credibility with engineering teams and make dramatically better decisions. And Skill 7, business acumen. Senior PMs understand unit economics, competitive positioning, and how features connect to revenue. The best PMs think like founders. They ask, if I were running this company, would I build this? And they can answer that question with numbers. Let's talk tools, because knowing the right stack signals to every hiring manager that you're already operating at a professional level. Core PM tools: Notion for documentation and PRDs, Jira or Linear for sprint management, Amplitude or Mixpanel for product analytics, Dovetail for user research synthesis, and Figma for reviewing and commenting on designs. Add Miro for virtual whiteboarding, Maze for rapid prototype testing, and Loom for async stakeholder communication. That's your full PM operating system. Learn these tools well enough to be fluent before you land the job, and you'll walk in on day one already speaking the team's language. Associate PMs start around $90K to $120K. Mid-level at Series B or FANG, $120 to $160K base, $140 to $220K total comp. Senior PM, $160K to $210K base, up to $320K total. Principal PM or director, $380K to $550K or more. San Francisco compensation from wherever you actually want to live. Before we move on, I want to give you the honest picture of how AI is changing this role right now. Because 92% of PMs say AI is already having a significant impact on their work. The coordination layer of the PM job, gathering status updates, generating first draft documentation, synthesizing research, is being automated. That's not a threat. It means the strategic layer becomes more valuable than ever. Tools like ChatPRD and Notion AI now let PMs generate a fully structured product requirements document from a few bullet points of requirements, in minutes, not hours. One SaaS PM reported cutting PRD creation time by 60%. You still apply the strategic judgment. The AI eliminates the blank page and the formatting overhead. The most forward-thinking PMs are building AI agent workflows, chaining together tools to handle multi-step tasks autonomously. Imagine an agent that reviews incoming feature requests every morning, clusters them by theme, cross-references the roadmap, and emails you a prioritized summary before your first meeting. Teams at Reddit and Twilio are running exactly this kind of workflow today. And this one changes the PM's discovery loop entirely. No-code AI builders like Bolt, Lovable, and V0 by Vercel let PMs go from a product idea to a functional, clickable prototype in hours without writing a single line of code. Reddit's CPO said it directly: idea to functional prototype in one day. The PM who masters these AI tools is effectively operating at the level of a team twice their size. Now, let's move to the role that builds what the PM specifies: the software engineer. The software engineer is the builder of the product trio. They take the PM's vision and the designer's blueprints and turn them into working, shippable software that real users interact with every day. Day starts with stand-up, 15 minutes. 3 questions. What did I ship yesterday? What am I building today? What's blocking me? Great engineering cultures protect deep work time fiercely. The real value happens in long, uninterrupted blocks, 2 to 4 hours of heads-down coding, fully in the problem. During those deep work blocks, an engineer is writing new feature code, debugging, which is honestly where most of your time goes, writing tests to protect existing functionality, and reviewing pull requests. A PR is when you propose code changes to the main codebase. Your peers review it before it gets merged. Afternoons shift to architecture and collaboration. Engineers join design reviews to understand what's being built next. They participate in architecture discussions, microservices or monolith, PostgreSQL or Redis. These decisions have multi-year consequences, and the best engineers think carefully before committing. End of day is deployment and reflection. Code goes through the CI/CD pipeline. Tests run automatically, then deploy to staging or production. Engineers monitor their deployments, watch error logs, and review tomorrow's work. That's the engineering day. And like the PM, it's all powered by a core set of skills that compound dramatically over time. Here are the 7 that matter most. Skill 1 is programming fundamentals. Data structures, arrays, linked lists, hash maps, trees, graphs. Algorithms, sorting, searching, dynamic programming, recursion, and big O notation. These aren't just for whiteboard interviews. Understanding algorithmic efficiency makes you dramatically better in production systems where every millisecond matters. Start with one language, JavaScript or Python, and go deep before going broad. Skill 2 is front-end development. HTML, CSS, JavaScript, non-negotiable. Then React.js, component architecture, state management with useState and useReducer, and hooks. Responsive design, accessibility, and core web vitals separate mid-level from senior front-end engineers. Skill 3, backend development. Node.js, Python with Fast API or Django, or Go are the most in demand. RESTful API design and GraphQL are essential. Database design, both relational like PostgreSQL and non-relational like MongoDB and Redis, determines how your application scales under real load. Skill 4 is system design. This separates mid-level from senior engineers more than any other skill. How would you build Twitter? How would you design a URL shortener handling 1 billion requests per day? Load balancing, caching, database sharding, microservices, message queues. Study this seriously. It's the core of senior interviews and daily senior work. Skill 5, version control with Git, non-negotiable. Branching strategies, pull requests, merge conflicts, rebasing. Your GitHub profile is your portfolio. A clean, well-documented commit history and pinned repos are your most powerful job application tool. Skill 6 is testing, and this is the one most self-taught engineers skip, then regret. Unit tests for individual functions, integration tests for how components interact, end-to-end tests for full user flows with Cypress. Test-driven development, writing the test first, then writing the code to pass it, will make you dramatically more hireable at serious engineering teams. Skill 7, DevOps and Cloud fundamentals. AWS, Google Cloud, or Azure. Know the core services. EC2 for compute, S3 for storage, RDS for databases, Lambda for serverless, Docker for containerization, GitHub Actions for CI/CD. Engineers who can deploy their own code are vastly more employable than those who hand off to the DevOps team. And a bonus 8th skill, AI augmented engineering. Engineers who use Cursor for code generation, GitHub Copilot for autocomplete, and Claude for debugging and architecture decisions are measurably 2 to 3 times more productive. This is now a professional standard, not a nice to have. For the tool stack, VS Code or Cursor as your editor, React and TypeScript on the front end, Node.js or Python on the back end, Postgres for your database, Git and GitHub for version control, Docker for containerization, Vercel or AWS for deployment. Learn one tool in each category deeply before adding the next. Depth beats breadth every time in engineering. A developer with deep React knowledge and a strong GitHub portfolio will outcompete a developer with 15 beginner frameworks every single time. Mid-level engineers, 132 to 175K base, 162 to 260K total comp. Senior, 175K to 220K base, up to 380K total. Staff engineer, 380K to 600K. Principal or distinguished, the ceiling starts to disappear. Every year of compounding experience plus equity events can produce outcomes that take most professions an entire career. Let me give you the most important data point on AI and software engineering in 2026. According to the Pragmatic Engineer's latest developer survey, 95% of professional engineers use AI tools at least weekly. 75% use AI for more than half of their work. The term vibe coding has been replaced by something called agentic engineering, coined by Andrej Karpathy in 2026, which is the practice of orchestrating AI agents to plan, write, test, and deploy code under your oversight. The two tools leading this shift are Cursor and Claude Code. Cursor, built on VS Code, has an agent mode that autonomously plans and executes multi-file edits. It hit $500 million in annual revenue in 2025 and is used by more than half of the Fortune 500. Claude Code is Anthropic's terminal-based agent. You give it a task, it reads your entire codebase, plans the changes, and executes. Both represent a fundamental leap beyond autocomplete. Beyond the editors, GitHub Copilot's code review feature now blends AI analysis with tools like ESLint and CodeQL to review pull requests, catch security vulnerabilities, and suggest refactors automatically. And AI can generate your entire test suite from existing code, unit tests, integration tests, edge cases in seconds. And this is the one that changes the career ceiling. Agentic engineering has made it possible for a single engineer with strong architecture judgment to build and ship products that previously required a team of 5. One founder built Base44, an AI app builder, entirely alone using agentic workflows. 6 months later, 300,000 users, $3.5 million ARR, acquired by Wix for $80 million. The engineers who develop deep architecture judgment and AI fluency are operating in a different league. The gap between AI fluent and AI tolerant engineers in delivered output is now larger than any other technical proficiency gap that exists. This is the new baseline. Now, the third role, the one most people sleep on. Product design is where psychology, visual art, and business strategy collide. The designer's job is brutally simple to describe and extraordinarily hard to do well. Make the product so intuitive, so clear, that the user never has to think about the interface at all. Morning belongs to research. A great designer starts by asking, what do users actually struggle with? They watch session recordings in Full Story or Hotjar, seeing exactly where users hesitate, click the wrong thing, abandon the flow. They read support tickets. They analyze survey data. This is the foundation that makes every design decision defensible. Mid-morning is ideation. Designers sketch on paper and whiteboards, not Figma. The goal is to explore as many solutions as quickly as possible before committing to any direction. Volume of ideas at this stage beats quality every time. Then it's Figma. Translating sketches into wireframes. Low fidelity first, no color. Wireframes are about information architecture and flow, not visual design. Once structure is validated, move to high fidelity. Design system, colors, typography, icons, micro interactions. Afternoon is design reviews, presenting to PM, engineers, CPO. The best designers treat every piece of feedback as signal, not a personal attack. They ask, is this feedback about the design or about the underlying product decision? And they advocate for the user when the business pushes for shortcuts. End of day is prototyping and handoff. Interactive click-through flows in Figma. Then, when a design is approved, annotated specs with exact spacing, typography scales, hex codes, and interaction notes so engineers can build it precisely. Let me break down the 7 skills that make this role worth $200K. Skill 1, user research and synthesis. Structured user interviews with open-ended questions, moderated usability tests, session recordings and heat maps, affinity mapping to synthesize qualitative data into clear design decisions. The best designers are the most curious people on the team about why users behave the way they do. Skill 2, information architecture. IA is the structural design of a product, how content and functionality are organized, labeled, and navigated. Card sorting, sitemap design, user flow mapping. The best IA is invisible. Users find exactly what they need without thinking about it. Bad IA is the source of most user frustration. Skill 3, visual design and design systems. Typography, color theory, spacing and layout, the 8-point grid, iconography.
A design system codifies all these elements into a reusable component library.
Building and maintaining a design system is a senior-level skill that directly improves team shipping speed. Skill 4, prototyping and interaction design. Paper sketches for fast ideation, low-fidelity wireframes for structure, high-fidelity mockups, fully interactive prototypes, and interaction design, hover states, click animations, loading states, error states, empty states. Every state a component can be in must be explicitly designed. Skill 5, design thinking. Empathize, define, ideate, prototype, test. The most critical and most often skipped step is define. Designers who spend time precisely framing the problem before jumping to solutions consistently produce better work. A well-framed problem statement is half the solution. Skill 6, data-informed design. Read analytics dashboards, set up A/B tests for design variance, interpret heat maps, tie design changes to measurable outcomes. A designer who says the redesigned onboarding increased activation by 28% has an extremely compelling career narrative and a very short job search. Skill 7, developer collaboration. Understand basic CSS and how browsers render layouts. Use design tokens that map to code variables. Write precise handoff notes. Be available during the build. Designers who treat the handoff as the end of their job produce products that look nothing like their designs. For tools, Figma is the non-negotiable core. Learn it deeply. Components, variants, auto layout, variables, the prototype panel. Beyond Figma, Maze for rapid prototype testing, Dovetail for research synthesis, Hotjar or FullStory for session recordings, and Zeppelin or Figma's dev mode for developer handoff. For advanced prototyping, Protopie and Framer go beyond Figma's native capabilities. Complex animations, gesture-based interactions, conditional logic. And FigJam for whiteboarding and workshop facilitation. Master these and you're operating at the level of designers at the world's best product companies. Senior designers, $155K to $210K base. Total comp frequently breaking $300K with equity. Staff or principal, $260K to $400K. Head of design at a well-funded company, $310K to $600K or more, plus meaningful equity. Design is one of the most remote-compatible disciplines in tech. I've spoken to designers earning $200K, working 4 to 5 focused hours a day from anywhere in the world. Here's the most important thing to understand about AI and design in 2026. And this comes straight from Figma's State of the Designer report. 91% of designers say AI has made their work better. Not easier, better. 73% of design teams have integrated AI into their weekly workflows. And companies using AI in their design process see an average 33% reduction in design cycle time. This isn't hype, it's the current state of competitive design practice. Figma Make, launched in 2025, lets you describe a screen in natural language and generates a fully structured interactive prototype, complete with state management and responsive behavior. The blank canvas anxiety that used to slow down early ideation, gone. You start evaluating and refining immediately, instead of building from scratch. Tools like V0 by Vercel and Framer AI are collapsing the traditional gap between design and engineering. V0 generates production-ready React components with Tailwind CSS directly from a Figma screenshot. Designers who bridge this gap, who understand how their work translates to code, are shipping final products that match their designs, with far less back and forth. Two more tools reshaping the workflow. Attention Insight generates AI-predicted attention heat maps of your static designs, showing where users will look before you've tested with a single real person. And Midjourney and Adobe Firefly let designers rapidly explore visual directions, mood, color palette, composition, in minutes instead of hours. Your job isn't to execute design anymore, it's to direct it. AI has not made great design easier, it's made average design cheaper. The $200,000 designer and the $90,000 designer both have access to the same tools. What separates them is user research depth, systems thinking, and the judgment to evaluate and refine what AI generates into something genuinely excellent. Now, the hack that ties all of this together. Here it is. Not a shortcut, a compression. It requires real work, but it compresses years of conventional career progression into months of focused effort, because it generates the one thing companies actually hire for: evidence of value. And in 2026, combined with AI tools, this works faster than it ever has before. Step 1. Find a real company. App Store, Google Play, G2, Product Hunt. A product in a space you genuinely care about. The more you care about the space, the better your analysis will be. Step 2. Become an expert in their users' pain. Read every 1, 2, and 3-star review. Watch user content on YouTube and TikTok. Read support communities. Find the 3 to 5 most recurring pain points. This is your product brief from real users for free. Step 3. Build a spec solution using your discipline. And this is where AI changes the speed entirely. Designers, a full Figma prototype, with Figma Make helping you generate the initial structure in an hour instead of a day. PMs, a complete PRD, with Chat PRD generating the first draft in minutes. Engineers, a working proof of concept, with cursor agent mode handling the boilerplate so you can focus on the architecture that actually matters.
Step 4. Document it as a case study. And this step is where most people cut corners and lose the opportunity entirely. Let me be specific about what a great case study actually looks like for each of the 3 roles in the product trio. For product designers, your case study needs 5 sections. The problem. What user pain did you identify and why does it matter to the business? The research. What reviews, session recordings, or interviews informed your decisions? The ideation. Show your early sketches and wireframes, not just the final polish. The solution. Your high-fidelity prototype with interaction notes. And the outcome. What metric would this move, and by how much? Even if it's hypothetical, frame it in business language. Activation rate, conversion rate, time on task. Numbers give your work credibility. For product managers, your case study is a written PRD plus a strategic narrative. Show the user problem in 1 sentence. Show the prioritization decision. Why this feature over the 10 others you could have built. Include a success metric definition, a 90-day rollout plan, and a section on risks and open questions. The open questions section is what separates a junior PM write-up from a senior one. It shows you think in systems, not just features. For engineers, your case study lives in your GitHub repo. But it's not just code. Your README needs to answer 4 questions a hiring manager will actually ask. What problem does this solve and for whom? Why did you choose this technical approach over the alternatives? What would you do differently if you built it again? And what would it take to scale this to 1 million users? A repo with clean code and a thoughtful README beats a resume with 10 years of experience and no proof of work every single time. 3 case studies built this way, 1 per role, or 3 within your target discipline. And you have a portfolio that reads like a track record, not a student project, not a tutorial clone, a demonstration of professional judgment applied to real problems at real companies. That's what gets the email back.
Step 5. Send it to the company. Every spec study compounds. 3 of these, and you look like you've shipped at 3 real companies. One company eventually says yes, and when you show up with 5 spec studies of their competitors, that's not a portfolio, that's a hiring case. You need one company, eventually, to say yes once. The product trio: PM, SWE, designer. 3 high-paying, remote-compatible, learnable careers, each with its own day-to-day, skill stack, toolset, AI advantage, and pathway to 6- and 7-figure compensation. And together, they build every product you've ever used. The people who break in fastest don't wait for credentials. They build evidence, shipped code, designed flows, written specs, before they're ever paid to do it. And in 2026, AI makes that evidence faster and more impressive to produce than ever before. If this gave you clarity, give it a like. Subscribe to Quiet Money Grows for the weekly blueprint on building high-paying tech careers on your own terms. No noise, no hype, just the strategy. See you in the next one.